right, this is 3.1.2, looking at the unit circle. So this pretty much piggybacks off of what we did yesterday at 3.1.1, just remembering and reminding ourselves of what radian measures are. So a lot of that applies here. The unit circle is a really specific situation we set up. And I want you to take a moment with your partner and try to figure out why it's called the unit circle. So I'll just give you like 20 seconds. So go ahead and turn to your neighbor. Why do you think this is called, in this case, a standard unit circle? Okay, I'll give you about 20 seconds for that. All right, wrapping that up, get your final thoughts there. And let's see. So what you may have come up with, let's look at this together. A unit, right? A unit. We don't know what units we're using here. You know, this could be inches, feet, meters, whatever. But we do know that the edge of the circle from the center, which is at our origin, the radius from the center to the outside of the circle is 1. It's 1. In this case, it's -1, just because going from the origin to the left is the negative numbers. And if we go down, it's also 1 distance away from the origin, but it's going down, so we say -1. So the key to this is that the radius for all these is equal to 1. And that's going to be really helpful, because we know that to go all the way around the circle, the circumference is 2 pi r, right? So thinking about that, what happens when we put in a value of 1 for our radius? Well, let's see. Ooh. Unexpected. We get 2 pi, right? So what that's saying is, when we are looking at radian measures, we are speaking about the angle starting from the initial side, right? The initial side, right here where the x-axis is positive. The initial side as this terminal side in red rotates around, we get an angle. This red arrow here is the angle that we're finding when we start from the initial and we open up to the terminal side over here. The terminal side is just the other side of the angle. So you can see that this angle here pretty much translates to approximately that, right? So looking at that, we know that if we were to rotate around this unit circle, starting at the original, we rotated all the way around, right? In essence, we'd be talking about the circumference. We'd be talking about the distance all the way around it. Since the radius is 1, the distance all the way around it is 2 pi. So looking at this, we know that it's all the way around. Radian measures to get all the way around is 2 pi. So how far is it going to be to go halfway around? If 2 pi is all the way around, how much is halfway around? A semicircle. Think about that for a second. So if I go halfway around, the measurement in radians for that angle, for a unit circle where there's 1 as a radius, is going to be pi. So, pi. Okay. To go all the way around is going to be 2 pi. And we could also think of it as it's either going to be 0 or it's going to be 2 pi, or if we go 2 times around, right? If we went 2 times around, it'd be 4 pi. Basically, just looking at this, if we know that halfway around is pi, all the way around is 2 pi, then we could figure out from this that up here this would be pi over 2, so half a pi, another half a pi gets you to pi. All the way around to this point would be 3/4 pi, 3 pi over 4. And actually what we're going to do, it breaks the unit circle up quite a bit more. So the idea is to break it up into 12 equal segments, and you end up with the different radian measures that are really helpful. Okay. So looking at this, we know that the unit circle is based on a radius of 1 from the origin. We have an initial side, we have a terminal side, and this angle, this radian measure that we have right here, is pretty much just going to be, it's going to be equal to how far we are rotating around, and that arc length will be the same measure. Okay. The other bit that we're going to look at here is the reference angle. So when we go to sketch these, or we try to get more information about it, the reference angle is basically looking at how far, what is the measure in order to get to the x-axis? So think about this like this. If you have, let's see, you have the unit circle and we're trying to graph where 5 pi over 6 is. Okay. So first I look at 5 pi over 6. If it was 6 pi over 6, what would that be? What's 6 over 6? It's 1. Okay. So if it was 6 over 6, we know that it would go, starting from our initial side, the terminal side would be all the way over here. This is if it was, right? Because that's over here at pi. This is if we had a, that's not right. So if we had 6 pi over 6, it would be equal to 1 pi, because 6 over 6 is 1, so essentially this is just equal to pi. So the reference angle, reference angle is helpful, because we know that if we went 6 pi over 6, then we would have equal to pi, so that would be a semicircle. But we didn't quite get there. We only have 5 pi over 6, not 6 pi over 6. So what I think about this is 5 pi over 6, to get to 6 pi over 6 is just adding an additional 1/6, right? 5 6, you add 1/6, you get 6 6. So watch what I'm going to do. I'm going to go ahead and make my terminal side here. We know that this angle here, this is pi over 6, 1 pi over 6, right? So knowing that that's true right there, we can then say that this terminal side was just to help us see this, okay? But what we see is here, this is 5 pi over 6, okay? So you're going to use the reference angle, basically just help you graph. You know, it's kind of hard to graph 5 pi over 6. If it was something a little easier, like maybe pi over 3, my strategy for doing pi over 3 would be to basically look at, okay, here's 0, here's pi. If we go half of a circle, we get to pi. So what I'm going to do is just break this up into, right, imagine it's not there. What we just broken it up is this value. Half of a circle is equal to pi radian measures. So pi over 3, it's helpful for me to break that. If this is all a pi, I break that into 3 equal parts. So from there, I know that here's going to be my terminal side. Here's my initial side. So this right here, this is going to be pi over 3. Okay? Pi over 3. Now, in this case, remember that the reference angle is only helpful in order to be able to sketch this. We were able to sketch this pretty easily here. But the reference angle is, remember, it offers a clue to the graph. It's always less than or equal to 90 degrees, or pi over 2. And it's also, you can think of this, it's always the angle to the x-axis. So in this case, if we look, our reference angle, it's always the smallest angle to the x-axis. Here's my reference angle right here. The reference angle in this case is equal to the radian measure of the angle theta. Okay. So looking at that, let's start to use that terminology again. So this is our theta. This was our theta. Theta is basically just the angle that you are measuring from the initial side to the terminal side. Okay, so that's kind of the basis. And honestly, this is just stuff where you have to see it over and over. When you get into the nitty-gritty of how you methodology for finding some kind of problems, we're getting to the problems right now, you're going to see that you start to catch on. You start to see patterns. Even if you're just looking to, I need steps, that's how I learned this. I want to just learn it by steps. We'll be making some steps, and you can follow them every single time. It's fine. But conceptually, this just might take a little bit of time to figure out. So let's look at some examples. Let's go ahead and sketch. We're going to sketch 2 pi over 3. So first step is to draw a unit circle. It doesn't have to be perfect. You're going to have compasses to use, and if you don't know how to use compass, then ask your neighbor. Ew, that's an ugly circle. Let's do that again. That's an egg. It's fine. All right, so we have a unit circle with 2 pi over 3. Now, with your partner, go ahead and remind me, what is this radian measure? To go halfway around the circle, what's the radian measure? So the initial side is always right here. The initial side is always right here. So theta in this case, or we're getting to it. We're first figuring out, just remembering, how far is to go half of the circle. So ask your neighbor. All right, bringing it back. We remember from the unit circle that from the initial side to the terminal side, if we go halfway around the circle, it's pi. Going all the way around was 2 pi. Remember that came from the circumference formula with a radius of 1. So here we know this is pi, right? So 2 pi over 3 is really 2/3 pi. So I need to get 2/3 of the way around. So again, this is where I can just say, I'm just going to get rid of this for convenience. I can go ahead and break this approximately into 3 equal parts. So what I've done is I've taken, I know this whole radian measure is pi, so I break them into 3 different parts here. So I know that this is pi over 3, right? Going to our terminal side here, I know that I need to go 2 of them to find my theta. In that case, we're going to have theta is equal to 2 pi over 3. Okay. So looking at that, we were able to graph it. And then it wasn't as helpful with this example, but my reference angle would be this. And my reference angle is pi over 3. And that might be helpful just to be able to see, well, if I know that entire distance of pi, right? The entire distance of pi is halfway around the circle. Then if I ease off that and I go back pi over 3, then I get to the point where the other angle involved has to be 2 pi over 3, right? So remember, we're going between the initial side and the terminal side. The reference angle is just helpful to figure out the best way to sketch this. So I'm going to give you an example problem now that's a little harder. Yeah, that's a hard one. Is that 5? 9. All right, let's do 5/6. Let's do 7/6. All right, how about this? 7 pi over 6. Okay? So first step, I like to draw the circle first and then put in a coordinate like that. 7 pi over 6. First off, is 7 pi over 6, is it more or is it less than pi? So if I think about this, 7 over 6, that's an improper fraction, right? This would become the mixed fraction of 1 over 1/6. So I know it's more than 1. It's greater than 1. Okay, so it's saying that this is more than just pi because it's 1 and 1/6 pi. It's more than 1 pi. So thinking about that, what I'm going to do is, I know that here's pi, so it goes a little further than that. It's going to go a little further than that. Our theta is going to go down here somewhere. It's going to go past. Okay. So here's the deal. If I go pi distance, pi would be 6 pi over 6. I'm keeping it in terms of sixths because that's what I'm dealing with. So if I go pi radians, then all I need to go is 1 more sixth. I have to go 1 more sixth, right? So I'm going to then go ahead and make my terminal. I'll do it red. My terminal side is going to be down here. Right? Terminal side of this unit circle. I know that my reference angle right here is pi over 6. Again, because if I go 6 pi over 6, that's 1 pi. I need to go a little further. I need to go another pi over 6. The reference angle is always just the angle closest to the x-axis, so that just helps us figure this out, that if we want to go have a theta of 7 pi over 6. First, we have to go 6 pi over 6. That's 1 pi. And we have to add another pi over 6. So that's how we use reference angles. That's really just a graph, which is like half of the classwork today. All right, for the next step, I actually need you to pull out your calculators. And looking at the calculators here, looking at the calculator, you may notice in the top or the bottom here, it says DEG, degrees, right? So we have to be very careful that anytime we're dealing with radians, if it's in degrees, we're going to have the wrong answer. You might remember this from last year. So when we are dealing with radians, we have to put in radian mode. And to do that, you just go to the DRG button. You might have to go further in if you have a different calculator than this. But you go into DEG or DRG, and that basically allows you to choose radian mode. You see how I just moved it over? Move it to degree, move it over to radian. And then I'm pretty sure I just put enter. Yeah. And now if you look close, down at the bottom, you kind of see it says radian at the bottom, right over here. See it in the screen? It should say radian. So double check you're always in radian modes when you're doing these type of problems. Anytime you're dealing with radians, you have to have it in radian mode, okay? When you're converting between radians and degrees, it's not that important, but we're going to right now get into my favorite thing. Your favorite thing too, if you forgot. It's nice one day, occasionally, when you remember your favorite thing that you forgot about. So what is my favorite thing? Well, I have many, but math-wise, it's this. And I'm so sorry if nobody taught you Sohcahtoa. Sohcahtoa, as far as trigonometry, which that's really what we're studying this unit. No big deal. Sohcahtoa tells me what sides are involved in a triangle in relationship to our theta. Those sides involved when we do the trig function, so for instance this is sine, like a stop sign, not sin. This is cosine. This is tangent. Cosine, tangent. So really what we're doing here is, how the heck can we have sides though? Because we have a unit circle, right? So we have a unit circle. We know that these are right angles. So the reason we have sides is, you could think of this. If here's my terminal side here. You could see that what we can do is we can drop. We can drop from the point where it intersects with the unit circle here. We know this is a distance of 1 because it's a unit circle. It's one radius all the way around. So what I know is, here's my theta, right? Here's my theta. And if I want to find, let's say I want to find this side. I want to find this side right here. Okay. I know that the hypotenuse across from the right angle, remember the hypotenuse? We have the hypotenuse across from the right angle. This is the hypotenuse. Okay. And you could think of, if I have theta right here, this is the opposite. Okay, that's the opposite. You might think of, think of like a projector in a movie theater. It projects straight forward, right? So it projects on the opposite wall of the movie theater. So if here's my theta, right, then the opposite wall is where the projection would project onto. Okay, adjacent just means next to, so this is our adjacent. But always figure out the hypotenuse, then figure out the opposite in relation to the theta, and then you're adjacent. Okay, so now looking at this, if I want to find this green side over here, and I know this theta, first off, what sides are involved? Okay, this is the hypotenuse. Over here, opposite. Here's the adjacent. All right. So in this case, I want to find the opposite side knowing what the hypotenuse is. So it's OH. Let's see. What do we have? OA, AH, OH, right? Sohcahtoa tells me, based on where theta is and what sides I'm interested in, as long as I identify them as hypotenuse, opposite, adjacent, then I could set up my trig function using that. So the sine is the opposite of hypotenuse. So we'd say sine of theta is equal to the opposite over the hypotenuse. The opposite of the hypotenuse. Okay. that helps us because here's the thing: we're trying to find what the opposite is and the hypotenuse is. And at this point, I'm going to go ahead and give you this theta. We'll define it. We'll define it in this. This theta is pi over 3. Pi over 3 radians. Okay? Pi over 3 radians. So I'm going to put in what I do know. Remember, once we figure out what equation we're going to use, all we need to put in is this information if we know it, that information, that information. And what's left over is what we're looking for. So watch, I'm going to go ahead and do sine of pi over 3. And that's equal to the opposite, which is what I'm looking for. Here's the opposite. So we're looking for the opposite. We know the hypotenuse is 1. Okay, it's going to get easy really quick. So I'm in radian modes. I'm going to go ahead and do sine, right? Sine. And then I'm going to put in pi over 3, and you can use the pi button, pi over 3. Everyone see how that looks in there? Right? Pi over 3. And you could put the last parenthesis up there if you want. It doesn't matter. So now I just push enter. And we're going to get to the 10,000th digit, so we're looking for the 4 digits. 0.8660 is equal to whatever the opposite value is over 1. Okay. Now remember, the opposite value over 1 is the opposite value. 6 over 1 is 6. 10 over 1 is 10. So the opposite side is equal to 0.866 units. Okay. So I just figured out that this opposite is 0.8660. That's my opposite. Okay. Now the adjacent is the next thing we're going to look for. We're looking for that right here. And let's go back now. And let's figure out which strict function do we use for adjacent. We know the hypotenuse, and actually we know the opposite now, but let's use the information we started with. Just in case somehow we were wrong about this, we use the initial information for the problem, and then we know for sure we're going to get this one. So we know the hypotenuse, we know the adjacent. Let's see, opposite adjacent, adjacent hypotenuse. Adjacent hypotenuse is cosine, so I'm going to go ahead and do cosine of my theta, which is pi over 3. And that's equal to the adjacent, which is what we're looking for, over the hypotenuse, which is 1. Okay, so just rewriting that. Since h is equal to 1, I could put 1 over, or a over 1, the adjacent over 1. But that side adjacent, I'm going to write it in there actually. Adjacent is the hypotenuse. I could write the adjacent over 1 because the hypotenuse is 1. But I'm going to leave that out because anything over 1 is just the same thing. 10 over 1 is 10, right? Remember that. So now I'm going to go ahead and do the cosine of pi over 3. I know I'm already in radian mode, so no worries. Divided by 3, 0.5. All right, we just figured out that the adjacent side is 0.5. Okay, so we have our sides now. The only other thing I want to bring up about this, and this is mostly it right here. This is, think about this. Our adjacent we just figured out was, along the x-axis, 0.5 from the origin. Our hypotenuse we figured out was 0.8660 away from the origin. You go up 0.8660, and that's this green side here. So what we've just figured out, is that this point right here, is actually at the point, at the location of 0.5 and 0.8660. Because anytime we're finding the sides of these triangles created by our theta here, anytime we find the sides, we're really finding where that point is located, right? Not the hypotenuse, but looking here at the adjacent is talking about the x values, and the opposite, in this case, was talking about our y values. Okay, so with this sketch, I hope that's attainable. You can see that. The other kind of shortcut to this is anytime you're looking for this point, where the point lands, okay, as far as the coordinate for that point, it's always going to be this. It's always going to be just the cosine of theta cosine of theta, and the sine of theta. If you know this reference angle right here, if you know the reference, if you know theta right there, theta, you take the cosine, you're going to find your x value for it. You take the sine, you're going to find your y value. Okay, so let's do one last thing. Find the point where the terminal side intersects the unit circle at pi over 4. So we're going to find, let's go ahead and draw a quick unit circle there. So we know we have, let's see, here's theta. Theta is pi over 4, right? So essentially we're looking at, here's our terminal side, that's where the angle opens up into. Here's always our initial side, that's how the angle's opening up. So all I have to do here is remember that if I want to find this point, if I want to find that point is at cosine theta, because that would be how far over along the x. And sine of theta, that's how far up you have to go, right? That is where that point is located. So let's go ahead and do it. And you know what? We can do it separate. Cosine of pi over 4. Then we'll find the sine of pi over 4. So looking at that, just putting it in, let's see, cosine pi over 4. That gives us, you're going to get used to seeing this number, 0.7071. And then, just for fun, I know what it is, but sine of pi over 4. Oh, what do you know? It is 0.7071. So you can see that because this is pi over 4, which is essentially 45 degrees, it's exactly in the middle here. So it is one of those situations where the legs are the same distance. That would be the same distance as that. And that's only in this case. You're going to have different situations we face coming up. But here is my x value I found by taking theta and taking the cosine of it. Here's my y. I take the sine of theta, and from there I'm able to get my point. Okay, that's about it for today. Looking at that, what else? No, that's all we have to cover today. So the main thing is, it's a special situation when we're dealing with the unit circle. Unit circle is 1 unit away from the origin. We have our initial and our terminal side. Theta is in between. Reference angle just helps us to sketch it because that tells us how many degrees, our radian measures, it is from the x-axis. Then we got into Sohcahtoa, which helps us to figure out the different sides of the triangle that's created in the unit circle, allowing us to get the points. Okay, so good luck with the classwork. We'll go over it tomorrow if we need to. And bacon.